Okay, this is the AB 3-6 review. Calculators are not allowed. Number 1, our goal is to find dy dx using implicit differentiation. So first we're going to do step 1, which is to take the derivative of both sides with respect to x. And as we go through this process, we're going to have to use the chain rule on everything that does not have an x in it. So, as we move this derivative operator through the 4, it's a coefficient, so the derivative moves directly through it, and then we hit the sign. The derivative of a sign is a cosine of its inside unchanged. Then we hit the x, and the derivative of the x with respect to x is just a 1. Hit the plus, move through it. Hit the cosine. Derivatives of cosines are negative sine of its inside unchanged. Now we hit the y, and the derivative of a y with respect to x is a dy dx. On the other side, we have the derivative of an x cubed, so the first thing we hit is the power. The inside remains unchanged. Decrease the power by 1, and then take the derivative of the inside. The goal is to find dy dx, so that means we need to isolate the dy dx. So everything that does not have a dy dx in it will move to the other side. Then, to get rid of the coefficient of the dy dx, we will divide by the negative sine y. Now, I don't remember if I leave it like this or if I, that should be a positive, or if I change the sign of everything and change it to a 4 cosine of x minus a 3x squared and put that over a positive sine y. So you need to know that those are equivalent to each other. You can change all the signs on the top and all the signs on the bottom, and you'll end up getting something that is the same. So now let's look at b, which works the same way. We again will take the derivative of both sides, and I'm going to write this as a sine y squared, and then I need the derivative of the y on the other side. So if I run this derivative operator through, it'll pass through this negative 6, it'll hit the cosine, so the derivative of cosine is a negative sine of the inside unchanged. Now we take the derivative of the inside with respect to x and get 1. The next thing we hit is this power of 2, so we'll do the power rule. The inside remains unchanged. Then we're done with the 2, so now we move to the sine. Derivative of sine is cosine with its inside unchanged. And the last thing we hit in this term is the y. The derivative of the y with respect to x is going to be dy dx. On the other side, we're taking the derivative of y with respect to x, so again we'll have a dy dx. Now again, the goal is to isolate dy dx, but it's showing up in 2 places. So I'm going to collect everything that has a dy dx on it on the left, and I'll move things that don't have dy dx's to the other side. So I will subtract this dy dx over, and then I'll add this to the other side. It's currently a positive 6 sign, so on the other side it will be a negative 6 sine of x. Now notice that dy dx is still appearing twice, but it at least is on the same side, so I can factor out that dy dx so that I have dy dx written only 1 time, and then I can isolate it by dividing both sides by the 2 sine y cosine of y minus 1. And again, I can write an equivalent version by changing the sign of the top and changing the sign of the entire bottom. Finally, last one, c. And I'll write it down here, and then I'll move so that we can see it. The final one, c, is we want dy dx. And again, we will take the derivative of both the left and the right. The derivative of this one, if I move it through, the first thing I hit is the cosine. So I'll have the negative sign of the inside unchanged. And then I need to multiply by the derivative of the inside. Notice that the inside is actually a product rule. So I'll have the first one times the derivative of y with respect to x, plus the second one times the derivative of x with respect to x, which is 1. And on the other side, I'll see the power first, inside unchanged, times the derivative of the inside. So again, my goal is to isolate dy dx. Now notice in this case that it is trapped inside a parenthesis. So I could divide this off, then subtract the y, then divide by x. But that will create a complex fraction over here. So it will actually be easier for me in terms of simplification, and since this is a multiple choice, I'm probably going to have my answers simplified on the exam. So I would distribute this term to both of these and then isolate dy dx. So when I do that, I'll have a negative x times the sine of an xy times that dy dx, and then I'll have a negative y times the sine of xy. Now notice I put the x in front and the y in front so that we don't accidentally think that they're inside the sine function, because they are not. Now to get dy dx alone, I need to add y times the sine of xy to both sides, and then I will divide by this. So my dy dx will be 2x plus a y times the sine of xy divided by a negative x times the sine of xy. And I'm pretty sure that's how I would leave it.